Hello, my name's Gail Murphy from the University of British Columbia. I'm grateful to be speaking to you today from the traditional, ancestral, and unceded territories of the Musqueam people on Canada's National Recognition Day for Truth and Reconciliation. Thank you for tuning in today to hear about creating usable and useful software tools. Over the years, my family's collected a large number of tools to build and fix things around the places we've lived. We easily have hundreds of the tools like you see on the screen. Software engineers also rely on tools to build and fix software. For instance, it's hard to imagine not using search tools, compilers, or debuggers to build software today. Every year, software engineering conferences are filled with ideas about new tools to help build software better. But few of these tools actually make it from those ideas into production and use. Is this just the way things are meant to be, that interesting research tools remain unused and described only in papers? Are there steps we can take to increase the likelihood that more tools proposed in research make it into use in industrial practice? Let's start considering these questions by thinking about what it means to have usable and useful software tools. And this means starting with an understanding of the difference of the words usable and useful. Let's first consider these terms in the context of physical objects like door handles. Both of the door handles pictured here are useful. They can both be used to open a door. But which one is more usable? The one on the left typically requires some dexterity to be able to grasp and turn the knob to open the door. The one on the right requires an up and down motion. Many might consider the one on the right, the lever, to be more usable because it can be used by more people in more contexts. In fact, in the city I live in 2014, they started requiring levered door handles because it can accommodate more individuals with disabilities. But do we know much about what makes a software tool usable and useful? Here are two tools that many might consider useful: search on the left and a file comparison on the right. Yet, are these two software tools usable? Well, developers certainly need to search the code and understand differences between the versions of two files. All too often a gap exists between such needs and the tools that are provided to developers to satisfy those needs. In this talk, I contend that attention to the usability and usefulness of software tools can help bridge that gap and can lead to tools that are used. Here is where I want to end up in this talk. I want to show you that an attention to usability and usefulness of software tools requires gaining an understanding through studying the context of use of these tools. Such study can lead to its own impactful research results. And when we get the usability and usefulness of tools right, it provides an opportunity, not necessarily an eventuality, for the tools to be used at scale. I want to convince you that studying the context of use of these tools is not only worthwhile. In fact, it's actually time for us to stop proposing so many tools and to see how we can move more tool ideas into practice for software engineering results to gain even more relevance. Here's a roadmap as to how we can consider usability and usefulness in software tool research that also serves as a roadmap for this talk. In the first part of the talk, we'll walk through these steps highlighted in gray to look at how tool development starts with identifying a problem. Then a tool is proposed, and then we need to iteratively consider how that tool will be used, build the tool, and then study if the tool indeed works for developers. I'll describe these steps using the PhD work of Anna Allertson from the University of Bergen. Anna has studied in depth how the usefulness and usability of refactoring tools can be improved. Then we'll take a look at some aspects of what it means to take a research tool and move it into practice. Here, I'll recap joint work with Dr. Mick Kirsten on taking the open source Mylan project into tools whose various iterations have now been sold for 15 years. Let's start with part 1, a case study of refactoring tools. If you remember the roadmap, we need to start by identifying the problem. The quote on this slide is from Bill Griswold's PhD thesis in 1991. Bill wrote, "Maintenance tends to degrade the structure of software, ultimately making maintenance more costly. At times, then, it's worthwhile to manipulate the structure of a system to make changes easier. However, it is shown that manual restructuring is an error-prone and expensive activity. This provided motivation for building automated refactoring tools. The next step along the journey of tool development is to propose a tool. Here we can see that several individuals first built proof-of-concept tools for automated refactoring 30 years ago. In 2000, Martin Fowler helped popularize the ideas with his well-known book, and we started to see automated refactoring tools, from simple ones like rename method to more complex ones like inline, appear in IDEs. Many common IDEs today support about 40 different automated refactorings. Now, if we return to the roadmap, the problem we encounter is that steps in the roadmap were missed. Instead of considering the context of use, tools were built presumably drawing on the experiences of the developers who were building the tools to define how those tools would be interacted with and used. Unfortunately, studies have since shown that there are a number of problems with automated refactoring tools, and in fact, these tools are disused. Study after study has shown that more than 50% of developers refactor manually instead of using these sophisticated tools. The overall conclusion is that refactoring tools are underutilized. Somehow, the usability of these tools is preventing their use. It is also unknown if the tools are actually useful. Many of these studies have also considered why refactoring tools are underutilized, with many hypotheses and reasons proposed, ranging from a lack of awareness by developers of the tools, to problems with the interfaces to the tools, to developers not trusting the tools. Despite these issues having been raised for a number of years, and refactoring tools remaining underutilized, few changes have been seen to the tools. In essence, they are tools sitting at the bottom of a tool chest, growing dust on them. But what if we took another look at these tools in the context of this roadmap? What if the step of considering the usage context hadn't been skipped? The first question you might ask is, what do I mean by a usage context? Let me return to the door handle example to explain the meaning of this term. If we were to study the usage context of the doorknob, as is shown in the picture, I contend that this is a study of the invocation of the knob as opposed to the usage context. While understanding how the knob turns can help lead to usability improvements, any modifications made to how the doorknob works consider just the act of grasping the knob, not the overall context in which the doorknob is being used. Similar studies have been undertaken for refactoring tools, such as when Murphy Hill and colleagues considered how to improve how code is selected when a refactoring tool is invoked. While these studies can be helpful, I contend they are often about fine-tuning a tool that exists, rather than considering if this is the right tool to exist. What I mean by considering usage context in the roadmap is to study the tool in use in likely tasks. Consider the usage context for the doorknob depicted on the slide. If you've ever been in this situation with a ton of packages in your hand and a need to turn a knob, you know what kind of acrobatics you tend to try to do. If the knob was a lever, you might have a chance because you can use an elbow to open the door. By considering the knob in the context of a common task, you can find that new requirements and new kinds of affordances or tools are needed. When we consider the context of tasks in which software tools are used, we can start to consider the interaction of usability and usefulness. And in fact, this is what Anna Ellertson did with refactoring tools. She conducted a study to consider whether, when, and how software developers used automated refactoring tools in change tasks. The study she ran involved 3 tasks on a non-trivial system that replicated the Apache Commons Lang project. 17 participants with industrial experience completed these tasks. It's important to note that in this study, participants were not instructed to refactor. As a result, it takes more of the form of the delivery man walking up to the door as a metaphor for the study design. The 3 change tasks on which participants worked were not random. They were modeled after changes made to other systems in which refactoring mining tools had post hoc determined refactorings had been performed. You can see in the row labeled Applicable Refactoring which refactorings these tasks were amenable to. Anna observed each participant and interviewed them after each task and at the end of a session. This resulted in 32 hours of video. The study resulted in a wealth of data about how participants approached the change tasks, including context about how and when they considered and used automated refactoring tools. It also resulted in a wealth of information about all the tools developers used when faced with a software change task. The tools on this slide are not likely a surprise to any of you. But in addition to the tools, it was also possible to learn about how software developers went about the change tasks. Through analysis of the data, Anna identified 3 strategies that were used by the developers. These strategies promoted or restricted the use of some tools. With a local strategy, developers were largely guided by the compiler. They would try changing a line of code and then follow the compiler warnings or errors to make compensating changes or to understand the effects of a line of code. With a structure strategy, developers tended to explore the change to be made using structural links in the code, such as who is calling a method. And with an execute strategy, developers prioritized keeping the code suite running as changes were made by frequently executing the test suite. While some participants had a dominant strategy that they used, we found that these strategies were distributed across participants and tasks. You can see in the figure on the slide the distribution of colors, both across tasks represented in rows of the table and participants represented as columns in the table. The kind of strategy matters because it helps define which tools may be a fit into their workflow and be useful to a developer as they progress on a task. Since we're focused on refactoring tools in this discussion, let's take a look at how these tools were considered and used by developers as part of the 3 change tasks. We'll zoom in on each diagram in turn. First, this chart shows which participants were aware of, invoked, and tried or used an automated refactoring tool during each of the 3 change tasks. The chart shows in 3 grouped columns the tasks from task 1 on the left to task 3 on the right. Each line represents a participant. The colors represent which was the dominant strategy taken by a participant to the task. You can notice from this depiction that most of the participants were aware of potentially useful refactoring tools across all strategies. Many of the participants tried to use the tools, and in many cases they were successful in that use. Not shown in the diagram is that many different kinds of refactoring tools were used, with more success with what we refer to as simple refactoring tools like rename than more complex refactoring tools. If we take another cut at the same data and organize it by the strategies employed in the tasks, we can see how many times the refactoring tools were used per kind of strategy and see that the use does cross-cut the strategies. We have 3 groupings of the strategies across the x-axis, 1 for each task. For each strategy, for each task, there are 3 bars. The first bar indicates attempts to use a refactoring tool, the second where the tool was tried, and the third how often the tool was used. The highlights on the slide show you this drop-off for the local strategy across all tasks. With 2 exceptions, you see that there is often a drop-off from attempts to tries to uses, reinforcing earlier findings that refactoring tools are underutilized. From this study, we extracted several themes about refactoring tool use in the context of change tasks. 2 main themes are shown on this slide. First, developers had difficulties controlling the impact of changes made by the automated refactoring tool. Many developers ended up surprised by changes the refactoring tool made to their code, and sometimes reverted the code back to an earlier state. Second, developers expressed that when they used an automated refactoring tool, they experienced loss of the knowledge of the code as they were unsure how the code had changed. These themes give us insight into challenges developers faced with the tools, but they do not provide concrete steps to improving the usability of the tools. To better understand usability aspects of the tools, Anna turned to the ISO definition for usability, shown on the left-hand side of the screen. This definition refers to such aspects as effectiveness, efficiency, and satisfaction of the use of a tool. To investigate in more depth the usability of refactoring tools, Anna proposed a theory of usability for refactoring tools based on this ISO definition. The theory states, Software developers employ refactoring tools to help prepare or complete functional changes to a software system. Software developers seek these tools to be reasonable to locate and apply for a desired intent to be effective, reasonable in terms of time and effort required to use the tool to be efficient, and to add value to the development process to be satisfying. She then proceeded to revisit the transcripts created from the 32 hours of developer actions during the change tasks as part of the study. She coded the transcriptions for these usability factors. The 5 usability factors considered are shown here. The first 3 come from the ISO definition. The last 2 come from previous studies of refactoring tools. You can see that all of these usability factors are stated in terms of the user and how they experience the tool. For example, a refactoring tool is effective if the user, a developer, experiences the tool as successfully performing a desired result. Coding the transcripts enables analyses of usability factors across the 17 participants. One analysis we ran was on the prevalence of remarks about usability factors by the developers. You can see that developers frequently commented on the predictableness, or lack thereof, of the tools. Given the amount of the literature that focuses on the behavior-preserving nature of refactorings, it may surprise you that trust was much less commented upon. Now you might be saying to yourself, that's great, but it's only 17 developers. To gain some broader insights, Anna used a survey that asked about software tools used in change tasks. There were 46 experienced respondents to the survey. Interestingly, the most used tool reported by the participants as part of change tasks was a version control differencing tool. You can see that the respondents were largely familiar with simple refactoring tools, and 67% reported familiarity with what we characterized as complex refactoring tools. The survey asked participants about what usability factors they seek in the tools they use as part of change tasks. The information gathered confirms many assumptions about what developers seek, while providing some interesting hints for future toolmakers. Here are some radar plots about the desired factors in a number of these tools. Developers did not think that either copy, cut, paste, or textual search tools needed to be satisfying. That is, to meet their needs or wants. Yet they did want these tools to be efficient and effective. Simple refactoring tools, in contrast, are desired to meet the needs of developers, and unsurprisingly, developers very much want their compiler output to be trustworthy. These kinds of insights can help guide the development of tools by allowing toolmakers a glimpse into the trade-offs between usability factors that developers desire. If we hone in just on simple and complex refactoring tools, you can see some differences. Developers want their simple refactoring tools to be satisfying and trustworthy more than they desire these features in a complex refactoring tool. There are many interesting research questions left to dive into here. So what did we learn about usefulness and usability of refactoring tools by studying this context of use? Well, we learned about themes of what developers desire overall in the tools that they use for refactoring, and through an analysis of the usability factors at a detailed level, we were able to propose a refined theory for the usability of refactoring tools that encompasses the fact that these tools are used as often as part of functional changes to a software system. Let's return to the roadmap. We've taken a deep dive into considering the usage context of automated refactoring tools by studying how these tools are used or not in the context of multiple change tasks. We've seen how we can use that information to understand themes about what developers seek in their tools and the usability factors they desire. This information can help us reconsider what kinds of tools are needed to support refactorings during program maintenance and evolution activities. Let's take a look at what that can mean for new kinds of refactoring tools. Using the knowledge she gained, Anna has proposed and built a proof-of-concept prototype of a new kind of refactoring tool, a class of tools she calls stepwise refactoring tools. I'll just give you a high-level overview of this class of tools. Anna presented a talk about these tools in the near track of ICSME 2021. If you use a refactoring tool today in an IDE, you typically invoke the refactoring and a number of preconditions are checked. If the preconditions are satisfied, you're presented with a preview window that allows you to see what will change as part of the refactoring and to typically select that some parts of the refactoring should not be applied. You can then apply all selected parts of the refactoring at once. It's this all-in-one step nature that is powerful with refactorings. However, it's also what leads developers to lose knowledge of their code and to be frustrated about a lack of control of the changes. To overcome these issues and others, Anna's stepwise refactoring tools enable a developer more incremental control of the code transformations, reminiscent of a debugger. To consider this in action, I need you to imagine how this tool works as I describe it. On the screen, in the code editor labeled 1, a developer has removed a parameter to the method m by just deleting that parameter. A pop-up appears, as shown on the screen, that notices that the parameter has been removed and equates that with a change signature refactoring, labeled as 2. With the refactoring recognized, the impacts of the change are determined, such as the new signature colliding with an existing method, labeled 3, and the places in the code that are impact, labeled 4. The developer can resort to an all-in-one refactoring by pressing the Apply All button, or enter into the refactoring as if it was a debugger, stepping through each part of the transformation and deciding at each step which steps to apply or not. This stepwise approach allows the developer to control the impact of the refactoring operation, a theme that emerged from our study of the context of use of refactoring tools. It also allows a developer to retain knowledge of the code as it changes by stepping through each part of the transformation. In addition, the stepwise tools can help improve usability factors such as predictableness and trustworthiness. What I hope I've been able to illustrate with this example is that when we consider the context in which the tools are used, we can use the information we gain to think about new tool designs that hopefully enable the tools to better fit the needs of developers and to be used more often. And you'll see in this roadmap that there is an iteration box around considering the usage context, building a tool, and then studying it in the context of use. The next step for a stepwise refactoring tool needs to be doing that studying in the context of use, which may, presumably, lead to more improvements. Then there will be a need to consider whether enough usage contexts have been considered, and so on, until the usage of the tools is sufficiently improved. I've provided an example in the context of refactoring tools, but this approach can be taken for both new tools being developed and tools that have been around for many years, but that might not have been meeting the needs of developers. I claimed at the start of the talk that consideration of usability and usefulness can lead to opportunities to improve the use of tools in practice. I would be remiss if I didn't try to say something about this claim. To do so, let me focus a bit on the bottom part of this roadmap using a case study of Mylar, also known as Mylan, and what grew into a company called TaskTop Technologies. This is based on joint work with Dr. Mick Kirsten. As you can see through the gray highlights, this is a focus on taking a tool that was proposed and deploying it through open source, and then growing additional refined and new tools from it as commercially deployed offerings. Another opportunity to move your tool into use is to license the tool to a vendor, say an IDE vendor. I'm not going to be saying anything about this option in the talk, but perhaps we can chat about it in the Q&A. I'm only going to give the highlights of this case study to illustrate points for this talk. I've talked about this journey in more depth in other venues. In 2004, Mick created Mylar to enable an IDE, in this case Eclipse, to be task-focused. The idea was to build a degree of interest model of what information in an IDE was helpful to each task being worked on based on a developer's actions as part of that task, and then to only show that information in the IDE with a high degree of interest. Early on, Mick conducted a small trial of Mylar with an industrial team, getting important feedback about its potential usefulness, but also aspects of the tooling that needed to change to meet the usability requirements of the industrial developers. Mick took that input and built it into the tool so that when Mylar was open sourced and a large field study run in 2005, there was more likelihood that the tool would work for developers in practice. There was sufficient interest in the tool that it became part of the default download for Eclipse, and as a result of that attention, and for potential trademark concerns, the tool was renamed from Mylar to Mylan. At the same time, Mick, I, and Rob Elves, a research engineer in my group at that time, had been working on ideas for commercializing a layer of source code onto the open source Mylan to make it more amenable to use by more industrial developers. Tasktop Technologies was incorporated, and Tasktop the software became a commercial offering, first to individual developers and then through enterprise sales. Feedback from customers over the years led the company to understand the value in moving some of the fundamental ideas in the software from the client side to a server. Fast forward to 2021, and Tasktop has continued to move ideas in this space forward to support value stream management of software delivery. The point I'm trying to make with the story is that all along this path, there's been a study of the tools in the context of use. Not as formal as the studies of refactoring tools I've just related, but close attention to how the users of the tool view the tools and what in their context they actually need. Tasktop is, of course, not the only company to do this. Most successful vendors pay attention to the needs of their customers. Along the way, Tasktop has both deployed its tool in open source and in closed source. I was thinking about what the lessons are I've learned through these different kinds of deployments. When deploying to open source, I'd highlight 3 lessons amongst many to keep in mind. First, design the architecture of the tool to enable contributions by others. This enables issues of usability and usefulness to be addressed not only by you, but also by others, and to help with those iterative steps of improving the tools. Second, welcome the community into the project by providing good instructions about how to get involved and be welcoming in community channels. Third, listen. Early on, there were some easily fixed usability issues with Mylan that once addressed helped with adoption. When deploying in general, whether open or closed source, it bears repeating that you have to provide on-ramps to users. What is obvious to you in using a tool is not likely obvious to others. We had a very helpful enterprise customer that pointed this out early on, and it led, at that time, to a series of videos modeled after martial art belt levels to allow users in the company to first use the tool and see value, and then incrementally layer in the use of new features and to see new value. All in all, I have learned that deploying is not for the faint of heart. It takes a lot of hard effort, but is very satisfying to see software tools actually used. What's interesting to me is that while continual attention to what tools are and how they work is more common in industry, we do not as often take a hard look at such aspects in research. So my roadmap diagram was a bit of a fudge to help guide you through the talk. In actuality, there is much more iteration that must happen to build software tools that are usable and useful to a large audience of practicing developers. Now, let me summarize this talk. But first, a bit of a shout out. I'd like to thank the organizers of ICSME 2021 for a chance to make this talk and present it to you today. Also, a shout out to all the fantastic students who have contributed to various ways that I think about software today. My wonderful colleagues at Tasktop that it's been a privilege to work with for 15 years, and to NSERC for the grant funding that's allowed a lot of flexibility in discovering new ways to think about software tools. And a special shout out to both Anna and Mick. It's been a privilege to work with both of them in trying to understand how we can make more software tools be used in industry. So this talk has been about the fact that we have given software developers an awful lot of tools to put in their toolbox. But way too often, those tools never get taken out of the toolbox and actually used. If we think more and study more about the usefulness and usability of these tools, I think we can do a much better job of bridging the gap between the tool ideas, the tool prototypes, the initial tool developments, and their actual use as tools useful and usable to practicing software developers in industry. In order to do this, we've talked about the fact that we have to get beyond studying a particular tool just at the moment that it's being used and start thinking about more of the context in which the tool should be employed and understanding what works and doesn't work for the users of the tool in those larger contexts. If there's one thing I kind of hope you take away from this talk is this image of the doorknobs and thinking when you're doing a tool evaluation where whether you're looking at the moment of use or you're looking at the context of use. I hope this roadmap that I've provided gives you a way of thinking about the different kinds of studies that we need to be doing in software engineering research. We need to not only be proposing that tool in response to a problem, but considering those contexts of use, building the tool, thinking about how the tool actually worked in those contexts of use, thinking about deployment and licensing potentially, but understanding that there's a great iteration that we have to do. And it's not usually a one linear flow through a roadmap like this. There's lots of questions that are interesting as researchers for us to address along this journey. If we think at a bit more of a meta level, are there classes of usage contexts that maybe fit different kinds of tools so that we don't have to come up with what those usage contexts are for each tool that we're interested in? How can we make the tools that we build fit more of the usage context we identify? And how might we auto-collect useful data about those usage contexts, particularly maybe as we start putting tools out into broader deployment? And overall, I think we have a lot of work to do in thinking about what is the right number of tools. How many tools do most developers need in their toolbox? So in summary, I hope I've given you a little bit of insight into what usability and usefulness might mean, how we might go about understanding the context of use, understanding what usefulness and usability look like in the context of how developers use tools as part of the work that they're actually performing. We need to do more of this kind of understanding and study within software engineering about tools. When we do so, we find even more research opportunities that we can study that I think can lead to very impactful research opportunities and results. And if we get this right, we create the opportunity for some of these tools to make it into large-scale use and to really change the lives of practicing software developers, a goal I think we have for much of the software engineering research that we undertake. So I hope you found this a little bit useful, and I would be happy to take questions and also engage in longer discussions if you have an interest in this area. You can find my email contact information pretty easily out there on the internet. Thank you for your attention.